Hello children, let us start the part D of refraction of light, critical angle and total internal reflection. Okay, these two are very important. Definitely you can expect one or two questions from this part. Okay, now first let us understand what it is. Now let us suppose, let us consider you have a light ray incident. Suppose this is glass, that means which is denser, and say this is air. Okay, suppose an incident ray is incident here at point say O, incident ray. Okay, now suppose this is the normal at this point, so this is the angle of incidence. Okay, so now since it is traveling from denser to rarer, it will bend away from the normal, and this is the angle of refraction R. Okay, this is you already known to you. Very good, no problem in this. Now suppose we increase this angle of incidence I. Now suppose we further increase, say here, so now I, this is say I1, now say I2. Now I2 is greater than I1, we have increased. So what will happen? It will bend further away from the normal. So this one will be the refracted angle of refraction. Okay. Now that means what is happening? The refracted ray is bending and bending towards the layer, this separation, the surface of separation, isn't it? This is the surface of separation between glass and air, right? Now for some angle of incidence, the refracted ray will coincide with the surface of separation. Do you agree? See, with for this angle instead of I1, the refracted ray was like this. When you increased I2, the refracted ray got further bent and it is bending towards the surface of separation, right? Now suppose you further increase the angle of incidence. Okay, so this is say I3, so that now the refracted ray passes along the line of separation. That means the angle of refraction is 90 degrees. So this angle of incidence I3, for which the angle of refraction is 90 degree, is called the critical angle. Is it clear? Okay. Now this diagram you will not be asked. You will be asked to define critical angle, which is very important definition. So did you understand the meaning? Now I will write the definition of critical angle. Critical angle is the critical angle is the angle of incidence in the denser medium corresponding to which corresponding to which the angle of refraction the angle of refraction in the rarer medium. This was in the rarer medium, right? This is angle R, which is, this is R3, which is 90 degrees, isn't it? Corresponding to which the angle of refraction in the rarer medium is 90 degree. So critical angle is the angle of incidence, that is this one, for which in the critical in which the medium, in the denser medium, glass, that is the denser medium. Okay, so critical angle is the angle of incidence in the denser medium, corresponding to which the angle of refraction in the rarer medium is 90 degree. Is that very clear? And this is very, very important definition that is asked. So is it clear? If you understand the meaning, you can write in your own words. Critical angle is the angle of incidence in the denser medium, corresponding to which the angle of refraction in the rarer medium is 90 degree. Is it very clear? And this critical angle is denoted by C. Okay? Is it clear till here? Now, the next thing, very important thing, is total internal reflection. Okay? Now, before we go to total internal reflection, there is a small topic, factors on which the critical angle depends. So, or the factors affecting the critical angle, or state two factors on which the critical angle for a pair, because this critical angle is different for different pair of medium. Okay, state two factors on which the critical angle for a pair of media depends. Okay, so the factors are, one is the color or wavelength of light. Okay, color or wavelength. Wavelength of light. Okay, and the other factor is the temperature. Okay, it depends upon the temperature of the medium. So temperature of the medium. Okay, now how does it change? How does it vary? How does the critical angle change with wavelength? So if you are asked, how does critical angle change with color of the light? So the answer will be critical angle for a pair of media. Critical angle for a pair of media is least or minimum for violet light and and maximum or the most, and n is maximum or the most for red line. This implies what in general? Critical angle increases with the increase in wavelength of light. Okay. Now with temperature, how does it change? With temperature, say how does critical angle change with temperature? So critical angle increases with increase in temperature. Okay, so that means critical angle is directly proportional to the temperature of the medium. So critical angle increases with an increase in temperature. Okay, clear? Now we will go to proceed to another very important phenomenon, that is called total internal reflection. Total internal reflection, very important. Now it is related to critical angle only. Now first you saw that the light ray, when it travels from denser medium to rarer medium, the angle of incidence, when it for certain value of angle of incidence, if the angle of refraction is 90 degree, that is the light ray, refracted ray passes along the surface of separation, then the value of angle of incidence for which the angle of refraction is 90 degree, we call it critical angle. Now suppose the angle of incidence is greater than the critical angle. Now let us see with the help of a diagram what will happen. Now suppose this is the surface of separation, this is your glass which is a denser medium, okay, and this is your air which is a rarer medium, okay. This is the surface of separation, okay. Now suppose an angle of incident, an incident ray is incident at point O. Suppose this is the normal. Okay, if this angle is equal to the critical angle, then it will pass 90 degree. The angle of refraction will be 90 degree, or it will pass through the surface of separation, which the refracted ray. Now, if the angle of incidence is further increased to greater than C, suppose here angle I is greater than the critical angle, suppose, okay, then when angle I is equal to critical angle, the refracted ray is going like this with refraction, angle of refraction as 90 degree. Now the refracted ray will bend towards the same medium. It will bend like this inside the same medium, glass medium, getting reflected, isn't it? So the angle, if angle of incidence is greater than greater than the critical angle, then what happens? The light ray comes back or reflects back into the denser medium, and this phenomenon is called the total internal reflection. Okay, so let me define total internal reflection. You will be asked to define total internal reflection. The diagram is only for your explanation. So you may be asked to draw with the help of a diagram, explain total internal reflection also. So this will be the diagram. Anyway, now let me define total internal reflection. When a ray of light, but mostly total internal reflection is asked to define. Okay, when a ray of light traveling, so if you understand the phenomenon concept, you can write in your own words. Traveling in a denser medium, this glass was a denser medium, right? Denser medium is incident. When a ray of light traveling in a denser medium is incident at the surface of a rarer medium. So here this is the surface of rarer medium, right? At the surface of a rarer medium, right? At what angle? At an angle of incidence greater than the critical angle, isn't it? At an angle of incidence greater than the critical angle for the pair of media, the ray is totally reflected back. The ray is this ray. Okay, the ray is totally reflected, this ray. Okay, I'm talking about this ray. Totally reflected back into the denser medium. Okay, this phenomenon is called total internal reflection. Okay, children, I told you these two phenomena, critical angle and total internal reflection, are very, very important from the point of view of examination. Okay, now I'll show you some more diagrams so that related to critical angle and total internal reflection, so that it will be more clear to you. See the diagram for critical angle. Can you see? Angle of incidence is going on increasing. When the angle of incidence is equal to critical angle, the refracted ray, the angle of refraction or the light ray passes through the line of separation. And when critical angle is more than when angle of incidence is more than the critical angle, then the light ray reflects back into the same medium. Okay, is that clear? Now this is here, this 90 degree is the angle of refraction. Okay, here it is wrongly written as angle of reflection in this diagram. Okay, this is angle of refraction. Clear? So what is it? Angle of incidence is going on increasing or increasing. At a particular value of angle of incidence, the angle of refraction becomes 90 degree. So that angle of incidence for which the angle of refraction is 90 degree is called the critical angle. Okay, so critical angle is the angle of incidence, angle of incident or angle of incidence in the optically denser medium, for which the angle of refraction is 90 degree in the rarer medium. Okay, is it clear? Now, another diagram I will show you for total internal reflection. Okay, so here what is happening? For when I is equal to C, the angle of refraction is already 90 degree, isn't it? This. When I angle of incidence is greater than angle of critical angle, then the ray reflects back. This is the case of critical angle when I is equal to C. Okay. So the angle of refraction is 90 degree. Right. This is the critical angle we are explaining. Okay. Now I will show you total internal reflection. Okay. So when I is greater than C, when I is greater than C, the refracted ray, instead of it bends towards the same medium, it gets reflected into the same medium. Okay, so this is the phenomenon of total internal reflection when I is greater than C. Okay, when is this? When I is greater than critical angle, right? Is it clear? Now again, the two conditions for total internal reflection are the light must travel from denser to rarer media and angle of incidence must be greater than the critical angle of the pair of media. This is another important question. They say, what are the or state this is another important question. State the conditions required for total internal reflection. For total internal reflection. Okay. So there are two conditions. The first condition, so first condition is what? The light must travel from denser to rarer. Light must travel from denser like glass to rarer like air medium. So that is a must. Then only total internal reflection will take place. Another condition is the angle of incidence must be greater than the critical angle for the pair of media. That is, angle I must be greater than angle C, where it means what? The angle of incidence must be greater than the critical angle for the pair of media. You must keep on mentioning whenever you say critical angle for the pair of media, because critical angle is different for different pair of media. Okay, is it clear, children, till here? Now you go through these two, these are very important. Now then I will continue with the next topic, that is total internal reflection in a prism. Okay, so thank you children for watching. Please go through both of these phenomena which are very important, both of the concepts, critical angle and total internal reflection. Based on this, now the next topic will be total internal reflection in a prism, which I will do in my next class. Thank you.